Yes. So, hi Riti, how are you today?
Hi Nilu, I am good.
Okay. So today we are gonna read about this adversarial attack on semantic classification, right?
Hmm.
So
Right.
here, uh, this is using two terms: adversarial attack and on semantic sentiment classification. So let's first understand what is adversarial attack. So this, let's say, this is an image of, let's say, any image, not only image, because there is one famous image of panda in adversarial attack. So I'm taking that example, but it can be any other image also. So let's say this is a image of panda with 60% confidence, and once you are adding some kind of noise, so this a noise with some ratio, then it machine will classify it as given with 99.9% confidence. So, and this is like it is making the machine full. This once we are perturbing any image with some noise, or then it machine make it full, right? So the convolution model train on that train on image in a data set is able to recognize this image as pandas, but model does not have whole I mean lot of confidence in that decision, to take decision that it is belongs to panda. This image is of panda, so there is 60% probability to decide the image of pandas, and 99.9% once adding this noise, this will move to this 99.9% of confidence to that it is a given image. Okay. So then, what is sentiment classification? This is just about adversarial attack, one kind of attack that makes a machine fool, and we can also modify the image. This we can also use to modify the image to create a convolution neural network to make a mistake. So this also used for this purpose. So there is some kind of models like linear models, or SVM, decision tree, nearest neighbor, or linear models like logistic regression. So these kind of models are easy to fool uh, if you are perturbing some noise in this image. So let's say how this adversarial attack effect of sentiment classification. What is sentiment classification? In NLP, this sentiment means sentiment analysis means you have some kind of text, because NLP work on lot of text data set. So you have lot of text, and like movie review text, or some comment or text on some image or some video. So that kind of that kind of comment, if you are you want to know that that is positive text, or that is negative text, or is it a neutral text. So this knowledge is about the text. What kind of text is it called sentiment analysis. And so the sent classification is like there can be three categories. First category belongs to this positive text. Okay, this is happy text. This is for sad text, or this is neutral text. So this that can be classification purpose. So how this is affecting these things. So first thing is, this paper proposes a white box approach, white box attack algorithm. So let me this highlight. So here this is this paper propose a white box attack algorithm called global search method, and they are, and then they are comparing that this proposed method, they are calling it global search, to a greedy search. That this is a common white box attack approach with noise. So for this purpose they are using CNN network to evaluating these things on IMDb movie review data set. So to find that whether reviews are good, is positive, negative, or neutral, right? So here they are also saying that results show that the proposed global search method generates a more powerful adversarial example with less distortion or less modification to the source text. So this algorithm we used to generate, here they are using to generate more powerful adversarial examples, means part of images or examples, not images, but this is about text, so part of text, you can say. So okay. And introduction is like this, they are showing the number of work have been done in this kind of field. So they are showing that uh, vulnerability in anything is a common task. If your system is vulnerable, then it can minimize the effect of attack. So uh, but if you are doing some manipulation on input, so then it is calling it as adversarial example. So but human can easily understand that, okay, this is a same image, but machine cannot understand that part of image with a small noise. So that might lead to different class. Okay. So there is some research that is showing that adversarial images that are if that are perturbing, then it can cause the algorithm to completely fail in computer vision. So this study of adversarial example in the application of neural network processing such as sentiment analysis, and where fake news detection, machine translation remains relatively low. So adversarial examples in application of neural network, natural language processing NLP examples are less for this task. So okay. So that's why this is a growing area. This is a this research area, booming area to research, and a lot of possibility of this thing, because these kind of tasks haven't done in the area of NLP. So some kind of Mm. So here, when generating how they are generating. So when generating an adversarial example, if the adversary does not have knowledge of classifier of training data, then they call this a black box setting. But if they have knowledge, classifier have the knowledge of training data, then it is called white box. So here you will see. On the other hand, if the adversarial has full knowledge of classifier and the training data, okay, so then it is called white box setting. So this is about two kind of setting. Yes,
Yeah.
Radhi, would like to add something?
No, no, it's okay. Mm.
Yeah, then you can mute yourself. Yeah. So in a black box setting, uh, this black box setting, this paper introduces a simple attack method by randomly replacing a character with their nearby key on the keyboard. So, which is similar to keyboard typo to a machine translation system. So, it seems like a black box is like you don't have knowledge. You have just you are about to write something, but there's kind of typing error, that is typos, keyboard typos. So similar idea can be found in the work of this paper, that the author generates adversarial, that is the Google Perceptive API by misspelling the abusive word or adding punctuation in the letter. So this paper also about that. So another work from the Al Jantot et al. Attempts to generate semantically and synthetically similar adversarial examples by some word replacement. So they develop an generic They develop a genetic algorithm that uses population-based gradient-free optimizations. So here they are just showing that only, and in the black box setting, the adversary try different perturbation, because black box you don't have knowledge about model and training data, so that's why in black box setting, the adversary try different perturbation and evaluates the quantity of perturbation by querying the model to get the classifier results in the output source. So this is about this adversary continues to alter the sentences until the model fails or until the score reduces significantly. So it's fine. I think it's easy to understand. So mm now what in white box settings, the adversary has access to the model, because this is a white box setting. So generally also in white box setting we have all knowledge. So in white box setting, the adversary has access to the model and thus is capable of generating more sophisticated adversarial example. So this paper is showing that the adversary example generates the white box setting achieves a higher success rate than the example generated in black box setting. So this is a obvious statement. If you have knowledge or if you don't have knowledge, these both terms are different. If you have knowledge, then you can make more example. You can do more work. Okay, so the author introduces a white box adversary, again differential classifier on that substitute characters the clips in a sentence. Okay, so this is about the black box and white box work that have been done, and yes. So okay, so because white box adversary has access to the gradient of the model. Yes, so white box adversary has access to gradient of the model. The adversary does not have, because it have information of data as well as information of model classifier. So the adversary does not have to query the output score of the classifier every time. So, using the gradient as surrogate loss, the white box adversary can efficiently find the best changes that maximizes that the surrogate loss simply by back propagation. So, if it have a knowledge of this gradient, if it has, because it is a white box adversary, that's why it has knowledge of gradient as a surrogate loss. So, so so what they want to say, the white box adversary can efficiently find the best changes that maximizes the surrogate loss simply by propagation, because the aim is to make more examples. Okay, so this is another work of field of white box adversarial, and this is include word label substitution, in which try to replace 10 to 30% of the word in the source text by solving an optimization problem that maximizes a surrogate loss subject using a greedy approach. So this white box, they are calling it as greedy approach, right? Yes. So which is similar to greedy search baseline used in the experiment. Okay, so greedy search algorithm is like you're being greedy. First you're finding more and more, and then you are going to less wait. So it was like that. Maximum profit. You are trying for maximum profit. So similar idea is also found in this Samantha and Mehta's paper, where the author applied different rules of insertion, replacement, and reduction of the word to generate adversarial examples. So this is, they also have done these things. So later combine the strategy about the strategies about the try to avoid introducing excessive modification or intersect insertions to the original source text. Okay, so in this paper, the main thing is, in this paper, they have considered the task of white box attack, where the adversary has full knowledge of model under attack. So they have proposed a global search attack method that mitigates some of the problem faced in the common used greedy approach. So what is mitigate? Mitigation is to solve. Uh, uh, very simple misspelling noise baseline is also reported to show the effectiveness of the two white box attack method in this experiment. So this is a general thing. So here and their attack methods uh, are how they are doing this misspelling noise, because they are talking about they have done some misspelling noise baseline. So misspelling noises, they first consider a very simple case by swapping two character in a word. So how they are misspelling that, they perfect into uh, perfect, right? So this is just a replacement swapping, which is similar to keyboard typos or misspellings. To maintain the readability of source text, the noise is only applied to word of length longer than 3 and 50% of the word in the text randomly swapped. Okay, so 50% of the text is randomly swapped for this task, misspelling noise. Okay, so then greedy search approach is they follow a similar greedy optimization strategy as this paper suggests for constructing adversarial example for sentiment classification. So how they are doing at each iteration, where is this? Okay, via greedy search, generate adversarial example via greedy search. Okay, so let's first say at each iteration the algorithm consider k nearest neighbor. What is k here? Is a k nearest neighbor of each word in the word embedding space. Okay, then it picks the picks the one among k nearer that has the greatest impact on the prediction results. So then it is picking that k nearer. Consider semantic sentiment classifier F. So what is sentiment classifier is F. The greedy approach forms the adversarial example by replacing the original word W with the candidate word W dash. So these are two words, that is original word, that is candidate word, that is replacing. Then here, so the label is positive, then the final sigmoid layer of the model should output a value sigma greater than 0.5. So if the algorithm that then replace the original word W with each candidate W does among the k neighbors. Okay, so that's fine. This is like W with each candidate W1 among k nearer replacement. Okay, so if the sigmoid value of adversary x is less than some theta, some sigma, that is function indicating the replacing w and w dash can contribute a flipping of predictions result to negative. So if less than this, then they are replacing that things. So to find that this is negative, candidate W dash that results in a maximum difference is then chosen to be final replacement. So smaller sigma dash is for positive, that in class 1, and larger sigma dash is for negative class. Okay, so sigma dash value is depending on this, whether it is positive class, belongs to positive class, or it belongs to negative class. So the function is like we are minimizing this x dash adversary using the sigmoid function. So if the sigmoid function over original text and adversary, then it is positive class, and if this part of one is greater than, then this is negative class. Okay, so what this algorithm summarizes? This algorithm summarizes a greedy search algorithm. Although the objective of algorithm is to fool the sentiment classifier, Yes, so this is objective of this algorithm, and the grammar, semantic, and sentiment should not be altered. Okay, grammar and semantic and sentiment should not be altered. Okay, so thus some constraint are imposed in order to maintain the similarity between the original source text and adversarial example. So this is algorithm that is finding that if positive sigma is less than 0.5, the return x test. If positive negative, then sigma is greater than 0.5. It means if its value is going beyond 0.5, that means it is negative example. Okay, so there is word choice also. When picking the word candidate in each iteration, they have considered the top k nearest neighbor in the word embedding space. So here, the nearest neighbor in globe word embedding space usually appear in the same context as the original word. So here they are using this globe vector, and by picking nearest neighbor in globe vector, they can ensure semantic similarity after the word replacement. So this way they are finding the semantic similarity. So although word embedding helps to find words that are used in similar context, it does not guarantee that the part of the speech will remain the same after replacement. Okay, therefore, they examine the part of speech of the original word and ensure the selected candidate have the same part of speech as the original word. So these are hyperparameter settings. Three hyperparameter they are using: K, D, and R. K is used to decide how many nearest neighbors should be considered, and should be considered in the first place. So, and if k is too small, there might not be enough candidate to successfully form an adversarial example. And d represent the maximum distance. D represent the maximum distance. What? Maximum distance allowed between the candidate word and the original word in the word embedding space. It's not like you have so long distance, maximum distance have to decide there. So when d is large, the meaning of altered sentence is generally further from the original one. So it means it have altered so much. So if d gets too small, that means the value of d is too small. That means the change of generating a successful attack decreases. Means there is less attack done on this. And also there is one more hyperparameter, that is r. So r decide the percentage of replacement allowed in the sentences. How much percent of replacement will allow in this sentence. So when the threshold r is too low, that means change of generating a successful adversarial example decreases. Similarly, when R is too large, too many words will be replaced, and thus the generated sentence will be very dissimilar to the original one. So, okay, so this is about hyperparameters and what these hyperparameters deciding. So that hyperparameter is deciding how much distance you have to take, how much perturbation you can do, and many more. Alright, so then they are using this global search approach. So the greedy approach proposed above does not guarantee to produce the optimal results, and sometimes find time consuming because of the need of search to the candidate word for every iterations. So this was the problem. So to mitigate this problem, they proposed a search for the candidates globally by computing a small perturbation theta, this delta. So this small perturbation delta they are using. So to learn the perturbation delta, uh, they define an objective function j delta. Why this j delta? To learn this perturbation delta. So the objective function tries to maximize the difference between the sigmoid values of the original input x and the perturbed input x plus delta to maximize the difference between the sigmoid value of the original input x and the perturbed input x plus delta. So if you are adding something, this delta, this means it is a perturbed image. Then how this is happening? So here you can here you can say, so this is regular. This is regularization penalizes large perturbation and is controlled via this parameter lambda 1 and lambda 2. So this is first parameter is lambda 1 hyperparameter that is used to regularization penalizes large perturbation. So this large perturbation is controlled by this parameter, and there is another delta 2 hyperparameter. So this is used to find the to regular, and the second regularization penalizes large distance between original word embedding and perturbed word embedding and is controlled by the hyperparameters, this hyperparameter. So two regularization terms are added to help keep semantic of chosen word. So for this purpose this have used. So this is like more on mathematical, but we have understand something from this is like they are adding some perturbation that is in anime. So this is just like syntax of all these, whether you can say that is embedding word embedding, input embedding, uh, and you are perturbing something in input embedding also. So this kind of and this is computes then for every tensor algorithm compute this gradient of the function j theta with respect to the perturbation delta, and then update the perturbation delta via backpropagation. So we then form a perturbed embedding delta x, not we they. And what else is important? This is like a general perturbation embedding. Uh, Ex is a matrix that each row is perturbed word embedding for each word denoted E. Okay, so here nothing much to read. Hmm. It's like some kind of perturbation is happening here, right? So this is a global search algorithm that we have discussed how this works. And so this is like taking some sigmoid function on original images round, and then initializes the success is equals to false and perturbation is equals to 0, and then doing some embedding, input embedding, and here they are doing this for E and EX. They are doing this empty candidate list. So they are appending this KE every time, and this is like then they are doing some kind of back propagation and part of embedding. So this is way of doing that. So experiment is done on this IMDb dataset of IMDb dataset. So we use dataset of 25 movie reviews from. Okay, so generally we can say they are using this IMDb dataset and randomly select 80% of the dataset to include in the training set and 20% for the testing or might be for validation set. And then they have used okay, for that 80% for training and 20% for testing, and then they use CNN for the sentiment as a sentiment classifier. So we know this CNN is convolution neural network, so they have used this network for this purpose. And success rate of doing this experiment is uh, what is this? So let's read this thing. So the end goal of attack algorithm is to trick the model to make wrong prediction by manipulating the input. To assess the effectiveness of the attack model, we select not we they select 500 examples. that are correctly classified from the test set. So the accuracy of the classifier does not affect the evaluation. Okay, so that is simple thing, like they have taken this they have selected this 500 examples, then input these source text into attack algorithm to generate the adversarial example. So here the adversarial example has then fed into CNN model. So this is like process. Once you have done this pre-work, then you are putting the data into a CNN classifier to find the final predictions. So higher success rate means the algorithm that can generate more powerful adversarial that can cause the CNN classifier to misbehave. So that was their ultimate goal. And for this global search achieves 72% success rate, while greedy search approach achieves 65 percent this 65% success rate. So yeah, this is all about basic things how the CNN working. Then it also seems that once you are doing this uh, experiment, this hyperparameter choices also matters. So they are just saying about all this they are saying about these three hyperparameters we were taking, first K, D and R. So these hyperparameters are values are also affecting up to some range. So K, the number of candidate to be considered. D is maximum distance allowed between the original and word, and R, the ratio of word changes allowed with respect to the length of the sentence. So what is this three? So these three hyperparameters are affecting this algorithm. So how they are affecting? So in their experiment they found, by they have changed these parameter to different values. So they found that the global search algorithm is more effective than the greedy approach, since the global search algorithm looks for the word that contributes most to classification results, while greedy algorithms swap word with any degree of contribution. Okay, so here is about perplexity. So, in order to evaluate the adversarial example generated from their model, they have decided to measure the perplexity. So, which is widely used for assessing what? Assessing language model. Okay, so these are four examples. Here in previous diagram, this is showing success rate versus word distance of local global search over greedy search. So for this success rate versus word distance, in word distance we can say that success this greedy search is performing well on this, and feeling a little tired. Yeah, so this is a success rate of attacking this model for greedy search and for global search. Okay. So this is perplexity, average perplexity. So if they're finding this perplexity, then this greedy search is working better than this. Hmm. In a similar way, this is average perplexity versus replacement ratio. The three terms we have taken now: word distance, replacement ratio. This is about that if you're changing this hyperparameter. So what else? So they also have calculated this perplexity with different values of proportional changes that we have seen from this graph, and the perplexity increases as the proportion of changes allowed in both attacking model. Okay, so this is about the diagram is showing. So human evaluation is like how him if human have to ask about what how much error is this, so they cannot see that kind of error. Like it is somewhat similar that panda image. So if human cannot easily recognize that okay this is having some kind of noise, but machine can. So in a similar way, if you are replacing or swapping that word for with some different swiping these words, so after that you might have seen that okay this is let's say this is criteria. So you are changing this e or r, but still you have this in your mind that okay this is criteria. So mm, now what? So the thing is sentence similarity, how they are finding this sentence similarity. So global search they are using for this purpose. So from global search is most similar to the original sentences with every similarity of this. And how they are doing this, they are choosing two sentences which is originally classified as positive comment and negative comments, then they flipped to opposite sentiment results after applying three attack methods. This is all about these things. Now what? Okay, so this is simple things. Now let's conclude this thing. See, this is one example of uh, global search, greedy search, and misspelling noise. So here you can say that global search which will search this words, but greedy search will search this leaf, blockbuster, telling whether it's hordius, these kind of things. Let's conclude this because I'm feeling so tired. So in this experiment, they generalizes the concept of adversarial example to the context of sentiment classification in natural languages. So they prove that some machine learning algorithms are vulnerable to adversarial examples. Some works have been done using the greedy approach and have proved the method to be effective. Yes, so however, the global search algorithm is proved to be much more powerful than the greedy search algorithm. So, global search algorithm method require less changes in the original sentences and maintains the higher level of similarity in the terms of both human evaluation and the perplexity measure. Okay, so this is like overall conclusions and. Other word label model operating on word sentences can be a way of improve the limitation of white box model. So this is like you if you use word label attacking models, then might be you can improve this. So I think that's enough, and we have been lot. Now let me stop this recording.